Welcome back, eCoreAcademy learners. My name is Anita and today I am bringing you a new installment in our Algebra 2 series. So today we're going to be talking about correlations and linear models. This is the first of 2 videos that I will be doing. So this is part 1, and then I'll be posting a part 2 to it because it's a pretty hefty little lesson I have for you guys. So I wanted to split it in half so you guys could absorb this first part, and then we could do the second part the next episode that I post on the channel. Alright, so before I get into it, I just want to ask you guys to please hit the like button on this video to show that you like this Algebra 2 course, and also subscribe so you can support the channel and so that you can be notified of our future content, so you can also follow along with this Algebra 2 series I am doing, because going in sequential order is really useful. To help you guys with that, with kind of ordering how you're going to be tackling this course, I've also put a playlist on the channel, so please go in the order that I've arranged the videos. It'll be super beneficial because that's the exact same order I learned during my Algebra 2 course last year in school. So please follow that order and access that playlist. You'll see videos that I did, like a review of Algebra 1. You'll also see all the TI calculator videos I did, and I ordered them specifically as in how you guys should be tackling each one of them to best learn how to use the TI calculator. We want to make sure you understand the concepts we're teaching you, so we are putting all the resources in your hands. So make sure you use them properly. Like I said, today's video is going to be on correlations and linear models. So we're going to be identifying characteristics of linear regressions. I know I keep saying the word linear regressions, but you guys might not know exactly what a linear regression is. So we're going to be reviewing some vocabulary, and hopefully you guys will get kind of the gist of what we'll be learning for this lesson, and then the next video I post for that lesson as well. So let's get right into the vocab. So this is some vocabulary and definitions that you guys should be familiar with before we start going into this lesson, so you guys know the terminology that I'm using and exactly what the definition is, as in what I'm applying it to. So the first word that I want you guys to familiarize yourselves with is scatter plot. So a scatter plot is a graph that relates 2 different sets of data by plotting the data as ordered pairs. So it's pretty much the relationship between an x-coordinate and y-coordinate. Scatter plots pretty much just display the relationships between these 2 coordinates. It shows how one coordinate affects another coordinate. If you guys think about independent and dependent variables, you'll graph them using the scatter plot to show how each one affects the other. So they're graphed as coordinates like a linear equation might be graphed. So they just, like I just said, they show the relationships between your x-coordinate and your y-coordinate. Second word that you guys should know are correlations. So correlations are the actual relationship between the independent and dependent variables. So when you identify this relationship, you want to graph it as a coordinate pair. So maybe you're doing a science experiment and you are kind of recording the temperature of a substance that you're heating up as time passes, and you're recording the time as the x-coordinate and the temperature as a y-coordinate, and maybe you're making a graph of all of these measurements that you're taking, and then after the experiment you actually make a scatter plot and you graph each of these points. So you're going to see kind of a graph. The graph might be linear, exponential, it depends on the actual experiment. So the relationship between the coordinates themselves, are they more of a gradual upward kind of looking curve? Are they gradually increasing? Are they gradually decreasing? Are the temperatures super far apart that you really don't see any kind of correlation or relationship between the coordinates? So that's what a correlation is, and we'll be looking at them later on, but just so you know, correlations can be strong or weak, positive or negative, or non-existent. Next is trend line. So a trend line is a line that best models the relationship between the variables. So once you graph all those coordinates, you're just going to have dots on your graph. So how can you connect these? How can you kind of make a prediction? If someone asks you, can you best make a model to kind of represent all this bunch of coordinates you have? So that's where a trend line comes in handy. So it's used to make predictions, as I've written down here. If you guys remember from the calculator videos, we graphed a bunch of coordinates that didn't form a perfect linear equation, because in real life applications you're not going to have coordinates that fall in a perfect linear equation. However, we want to see a prediction that can best represent those points as a linear equation. So in order to make that prediction, we graph the trend line. It's also known as the line of best fit or linear regression. We graphed that trend line. It kind of passed through those points, if you remember, but it showed the best approximation of a possible linear equation that kind of struck all those coordinates. So it kind of averaged those coordinates distance from each other, and then it graphed a line that best represented those coordinates if they actually belong to a proper linear equation. So those are some vocabulary words I want you guys to know about. If you want, pause the video and just read over them. Make sure you understand them. Also, Google these words if you want to know further definitions, if you want to see actual pictures of what a scatter plot might look like or what a correlation is. You guys can definitely do that. But in the next slide, we'll be getting into what correlations actually are. I'm going to be showing you some correlations. So we're going to be looking into correlations mainly for this part of the video. So again, correlations are the relationships between x coordinates and y coordinates. So we're going to be understanding those relationships, how to graph them, what they look like on a graph, things like that. So these are all going to have real life applications, which we'll be tackling in the next video. But I want to show you guys what correlations are in this video and just review how to do them on the TI calculator. So let's get right into it. So let's look at some types of correlations. So like I said, these are the 6 main types. You guys remember I said there's strong, weak, positive, negative, non-existent. So these are the 6 main ones I found on the web. I'll put this link in the description box if you guys want to see like an actual picture of it. I just kind of cropped each of these pictures out. And these are the 6 main ones you typically see when you do these linear regressions. So the strong positive. If you guys see, the lines plotted here, the points plotted here don't form a perfect linear equation. If you see, some of them are stacked on top of each other. They're not forming an exactly perfect line. But if you see, when they're graphed, they kind of form a pretty good semblance of a linear equation. They look like a line. They're pretty close together. So that is a strong positive, because if you see a positive line increases from left to right. The x coordinates increase with the y coordinates. So this is considered a strong positive correlation, because correlation is the relationship between the x coordinates and the y coordinates. It's positive because it's increasing from left to right, and it's strong because these points are grouped close together. They look like a line. This one next to it is a strong negative. So if you see the same scenario with the points, they're really close together. They look like a line. If you guys looked at it far away, it kind of resembles a line. They're very close together. So that's the strong correlation. The negative part of it, it's decreasing from left to right. So as the y coordinates increase, the x coordinates decrease. So that is a decreasing equation. That would be a decreasing linear equation if it was an actual line. So this is known as a strong negative. The next one, moderate negative. So let's look at the negative part of it first. Like I just said with the last example, it's decreasing from left to right, so it's negative. It's moderate because if you see here, these plotted points, they're not very close together like this previous one. This strong negative looks like the semblance of a line. It looks very much like a line, even though it's not a perfect line. However, this moderate negative, these points are a little bit farther apart. They're a little bit more scattered, a little bit more sporadic. They don't look as strong as this one. They're not as consistent and clumped together. They don't resemble a line as strong as this one. However, they're not like all over the grid, so we would consider it moderate. It's not that bad. The next one I want to show you guys is a weak positive. So it's positive because if you see from left to right, generally the points are increasing. So from left to right, it's increasing. As the x coordinates increase, the y coordinates are increasing generally with all these coordinates right here. However, it's weak because it doesn't look anything like a line. These coordinates are really far apart and they just kind of look like a blob on the coordinate grid. So it's a weak kind of correlation. The one right next to it is a weak negative. So generally looking at it from left to right, the coordinates are decreasing. So as the y coordinates increase, the x coordinates are decreasing. So it looks negative compared to this weak positive. However, it's weak because again, it doesn't resemble anything like a line. It's just this blob on the coordinate grid. These points are very scattered apart. They don't really make a good line. And lastly, this is none. So if you see here, I can't really tell if it's increasing from left to right or if it's decreasing from left to right. So I won't be able to say if it's a negative or positive correlation. As for if it's strong or weak, it's really weak. Can you really make a line out of these points right here? I know it's a really small portion of the coordinate grid you're looking at, but still, all the points are scattered across this little part of the coordinate grid they're showing you. The points are really scattered apart. It is an extreme blob. for lack of better words. So there's no correlation between the points. They're just random points on the grid. So therefore there is no correlation in that one. So just ask yourselves these questions when you're looking at scatter plots and trend lines. What kind of correlation is it? So the next part of this is going to be how to tackle some applications. So we're going to be solving real-world problems of linear regressions, but that will be saved for the next video. First of all, I want to address what's in this box right here. So these are steps we are going to be following to tackle applications with these real-world linear regressions. So in the TI calculator videos, I showed you guys how to plot coordinates and how to find a line of best fit for them, if you guys remember from those videos. However, I never really explained to you guys how we will use them. So we're going to be using them for linear regressions. You might be given a word problem where you're given a table of points, and let's say when you graph those points, they don't form a perfect line. Well, you're going to need to know how to make a prediction on the calculator to find a line of best fit for you, so you're not sitting there making a line of best fit and trying to find the equation of that line for yourself. So therefore, we're going to be doing a review of how to use the calculator in that scenario. We're going to learn how to put values into the table if you forgot how to do that. We're going to be calculating the regression, as in making a prediction, and I'm going to show you how to do it on the TI-83 and the 84. Then we're going to be predicting X values using that line of best fit you found, and we're going to be predicting Y values. So that's what we're going to be doing with the TI calculator. I'm going to switch my view for the next screen so that you guys can actually see my calculator, and I'll also have a blown up picture of the calculator on the screen. If you guys have an 83 or 84, please grab it and follow along. I don't have an 83, so when we approach how to calculate the regression on the 83, I have instructions on the screen, so please read over those and try it with your own calculator. I'll try to guide you as much as I can. So let me stop talking for now and let's get right into that part. So I'll be right back with the clip of my calculator. Hey guys, welcome back. I have the new clip where my TI calculator is on the webcam and I have the blown up calculator up on my screen along with the instructions for each step I'm going to do. If you have a calculator, please grab it and follow along. Feel free to pause the video. Because this is a review of one of my previous TI calculator videos, I will be going through this review pretty quickly, so feel free to stop this video and read the instructions as you need to. Without further ado, let's get into this first subject, which is inputting values in the table. So let's first, since I don't address this in the instructions, I'll first show you how to put values into the table. So make sure your calculator is on. You want to go to stat, the stat key. The stat key is right here. If you guys look up at the picture, the stat key is here. Then you want to hit 1 for edit, and the one is right here. And then you have your L1 and your L2 tables. So your L1 is your X coordinates, L2 is your Y coordinates. So I'm just going to put a bunch of random coordinates that kind of resemble one another, kind of resemble a linear equation. Feel free to copy what I'm doing on your screen. Yeah, I'm just going to put a bunch of coordinates in. And yeah. So those are the coordinates I put in. So for example, that would be read as 0, 1, 1, 3, 2, 2, 3, 5, 4, 3. So these are the coordinates I put into my calculator. So now that I've put them in, I want to graph them. So if I hit graph, the graph key is right here. It's right next to the trace key. If I hit graph, it's not graphed because we're still on the regular coordinate plane. So we need to enable scatter plot. After you've entered your coordinates, you need to plot them on the graph, and because we don't have scatter plot enabled, we need to enable that. This is because you're not entering a normal equation in your y equals. So in order to enable scatter plot, you want to hit the second key, which is right here. Then you want to hit the y equals key, which is right here. Then you want to hit 1 for plot 1, and then you want to hit on. You can use the right arrow or the left arrow to get to on, and then you hit enter to confirm that. For graph type, you want to choose the first one, which is a scatter plot, and hit enter to confirm that. Your X list should already be set to your L1, and your Y list should already be set to your L2, as we did in this in our graph right here. We want to make sure the corresponding X and Y coordinates are correct. And then you can select a color marker for your coordinates. All right, so let's actually do this here on my calculator. To enable scatter plot, you need to hit second, and then you need to go to the y equals. So if you see stat plots, you have plot 1. So I'm just going to press 1, and then I'll go here to this new screen. You see on the instructions, I have to make sure it's on. Right now it's blinking over on. To confirm that, I just hit the enter key. So I just hit the enter key to to get it on. So then for graph type, I want to make sure it's on scatter plot. Mine's already on scatter plot, but if yours was not, you can just use the left arrow to get to scatter plot and hit enter to confirm your choice. My X list is already on L1 and my Y list is already on L2, so that's set. My color is blue, which I'm totally fine with. I don't really care about that. So now that this is all set, we're good to go to the next screen. So now we want to first graph our points. So if I hit graph, if you see my 5 points are graphed right now. So now I want to calculate the regression, as in the line of best fit that goes through these points to the best. So if you have a TI-83 and older, you guys want to use the instructions I have up on the screen right now. So you're going to calculate the linear regression because you want to best connect your points and make that prediction of a line of best fit. So if you just want to read over the instruction on the screen, feel free to do so and pause. First, you want to hit the stat key. Then you want to hit the calc. Then you want to hit the calc button. Then you want to hit 4 for linear regression, which is ax plus b. You'll see that as the fourth option. Then you want to hit the second button, and then 1. And then you want to hit the second button, and then 2. And then you want to hit the vars key. Scroll over to the y vars menu. Hit 1 for function. Hit 1 for y1. Hit the enter key. And then hit the graph key, and then you'll be set. Again, because I don't have a TI-83, I can't demonstrate for you guys, but please feel free to pause the video and do that for yourself. And just, and these instructions will work. Just make sure you follow them in the right order. And if you can't see your equation properly for some reason, make sure you go to window and then fix your viewing window. All right, let's go to the next screen where I'm going to be showing you how to do it on the 84. I actually have an 84, so I can show it to you guys here. So you want to calculate the regression model. This is for TI-84s and later to best connect your points, again, because you're trying to find that line of best fit. So first you want to hit the stat key, which is right here. Then you want to go to the calc menu, and then you want to hit the fourth option, which is linear regression, which is ax plus b. Then you want to make sure your x list is already on L1 and your y list is already on L2, because if you remember from our graph that we input into, those are the corresponding x and y coordinates. Yours should already be set up that way, but just make sure it is. Then you want to hit second stat, and then make sure your frequency list is blank. Make sure your store regular equation is so then you want to use the down arrow to get to your store regular equation. Then you want to hit the vars button. Then you want to scroll to the y vars menu, hit 1 for function, and then hit 1 again for y1. Then you want to go back to your original menu, scroll down to calculate, highlight calculate, hit the enter key to confirm calculate, and then you want to hit the graph key. So then that's how you get over linear regression. I know that's a lot of instructions, but let me show you here on my calculator. So first I want to hit stat key, and then I'll have the menus at the top, edit, calc, and test. I want to go to calc, so I'll use the right arrow to get to calc. And then after that, I want the fourth option, which is linear regression. I'm just going to hit 4 on my keypad. I get 4, and then I'm taken to this new screen. I make sure that my X list is L1 and my Y list is L2, which is perfect. Then I want my frequency list to be blank, and then for store regular equation, I want to hit vars. Again, the vars button is right here where my index finger is. You want to hit vars, and then if you see these top menus, you want to hit the right arrow, go to Y vars. Then you want to hit 1 for function, and then just hit 1 again for Y1. And then you hit the down arrow, go to calculate, make sure your cursor is on calculate, and then you just want to hit enter. And now this is your linear regression. So A is your slope, which is m, and B is your y-intercept, which is b, like a normal linear equation. So the line of best fit, the linear equation would be y equals 0.6x plus 1.6. So that's how you would read this. Okay, so let's see the line of best fit actually graphed. So I'm just gonna hit the graph key. And if you guys see that line of best fit just goes through these points, it averages the distance between these points and then comes up with a line of best fit to go through these points. So this is much quicker than doing it by hand. And again, if this is not visible perfectly, as in if you can't see all these coordinates, please go to your window and then just change your window options, because I can see them. And if you go to the standard viewing screen, you should be able to see them. We're fine for now. Okay, let's go to the next screen. So now let's say you want to predict some x value. So let's say you were given predicting with x value. So let's say you were given an x value and you're trying to find the corresponding y value. So in order to do this, you want to hit the second key, and then you want to hit the trace key, which is right between the zoom and graph key. Then you want to hit 1 for value. Then you want to input the x value that you were given, and if you hit the enter key, you'll get its corresponding y coordinate. So let's do that here on the calculator. So I'm going to hit the second key first, And then I'm going to hit trace to go to the calc menu. And then I have these options. I want 1 for value, so I press 1. And then it's asking me for what x value. So I'm just going to say my x is -1, so I'm trying to find the corresponding y coordinate. So I just typed in -1, and then after that, I want to hit enter. So it gives me the corresponding y coordinate. So y equals 0. On this linear regression, it's making a prediction if there was a coordinate at -1, 1, the x coordinate will be -1 and the y coordinate would be 1. That's just the prediction that the line of best fit is giving me. Okay, so that's how you would find x values given the y value. So let's go to the next screen. This is a little bit trickier. If you were given a y value and you're trying to find the x value. So first you want to hit the y equals key. And then whatever your y value is equal to, you're going to type that. You're going to have your original line of best fit equation in y1. Don't touch that. So hit the down arrow, go to your y2, and then you want to type the value of the y coordinate you were given into y2. Then you want to hit the graph key, and then you'll see that y2 equation appear as a horizontal line that intercepts your line of best fit. Then you want to find the intersection between those 2 points because that's your answer. The x coordinate of that will be your actual answer. So then after that, you want to hit second, then trace, and then you want to hit 5 for intersect because you want to find the intersection. Again, second is right here, and then trace is right here, and you'll be taken back to the graph screen, and you want to hit enter, which is down here, 3 times. So let's do that here on my calculator. So first, let's go to the y equals key. I'm just going to make this up. So I'm going to scroll down to my y2, and I'm just going to say my y coordinate is going to be equal to 5. I want to find the corresponding x coordinate that goes with this. So now my equation is in my y2, so I want to hit the graph key, which is right here to the right of the trace key. You see a horizontal line has been drawn on the calculator where it's equal to 5. So the equation of this line is y equals 5. If you see right here, it intercepts. We want to find the exact place where these two intercept so we can find the exact x coordinate. In order to do that, we want to hit the second key, which is right here, and then trace, and we're taken back to that calc menu. So instead of 1 this time, we're going to hit 5 because we want to find the point where these two intersect. So I'm just going to hit 5. And then I have this blinking cursor. So right now it says first curve. The calculator is asking me first curve. Again, this is not your answer down here. So it's asking me first curve. So I'm going to hit enter for the first time. Second curve, hit enter for the second time. And then guess, I'm going to hit enter for the third and final time. So it's going to give me the exact place where it intersects. And here the exact x point is 5.66666, which is 5 2/3. So that's the exact x coordinate. So again, this is if you are given a y coordinate and you're trying to find the corresponding x coordinate. That's how you would find these out with linear regression and using a horizontal line. So that's how I have for you guys today. Again, that was correlations in linear models. We looked at we went over some vocabulary first, then we looked at some correlations as in positive and negative correlations, weak and strong correlations, and non-existent correlations. And finally, I just reviewed with you guys on the calculator how to apply correlations, lines of best fit, and scatter plot to your calculator so that you can get these problems done even faster. In the next video, we'll be looking at some actual applications. I'm really excited for that one. As of now, we're done with this video, so please like and subscribe. Also, share with your friends, please. We have all these different social media up. We have Facebook, Twitter, and Instagram. So all of this will be in the description box, so please follow us there so you can get notified of our latest content. And again, please share with friends and family. Our website will be going up soon, so please stay tuned so you know when that goes up. And finally, if you have any suggestions or questions, please contact us. If you have any business inquiries or you want to contact us privately, please email at us eCoreAcademy@gmail.com. Also, please drop a comment on what you thought about this video. It would be really helpful and motivating. And if you have any suggestions, that will be taken into account as well. Again, please stay safe during these times. I know that it's really uncertain, but again, this is the time when we can be the most productive and really make a difference in the world, on other people, and we can even change ourselves for the better. So please use your time constructively, and if you get involved in our community, that's one of the best uses of time. So I really hope you guys enjoyed this video, and I will be coming back to you with a part 2. Have a great day.